Okay, so we're going to watch this. I'm going to do a really quick introduction to Newton's first law. We'll do some demos in class tomorrow. Before you've watched this, I hope you've already watched the BMW video that I posted on Moodle about Newton's first law. It's like a demonstration of it. And I think that's kind of a really cool video. However, I will say that Mythbusters, I guess, tested that one and they weren't able to recreate it. So I don't know if that's a trick video, that particular one, or if it's just the fact that the Mythbusters team couldn't recreate that particular one. Either way, it's a cool idea and a cool example of Newton's first law and of inertia. So very fast, a very quick history of motion and how we got to where we are in terms of what we believe about motion. It kind of starts with Aristotle, who had some wrong ideas about motion, but they were kind of from the observations of what he saw, because he thought every time he saw something moving that it was being pushed, and so he thought in order to make something move or to get it to do motion, to have motion, you have to put a force on it. And that's not actually true. It turns out that objects will tend to want to move or stay in their same state, and actually to make them change their motion, you have to put a force on them. But he didn't quite get that part. It wasn't until Galileo came along and Galileo recognized the role that friction plays in it and how friction tries to slow something down. And so it was Galileo that first recognized that if you leave something alone and you don't have any friction on it, it will not want to slow down. So it was friction that actually was slowing it down. And you can see that Newton's life began right around the time Galileo's life ended, so Newton was had the advantage of being able to use the thoughts of Galileo with his in his experimentation and his theories. So it was Newton that kind of tied all of this together, this idea that, you know, how an object moves and how much force you have to place on it to make it move. So he figured, Newton thought that whatever an object's doing, that's what it's going to want to keep doing. And he called that property of wanting to keep doing something, he calls that inertia. So every object has an inertia. It's related to its mass that makes it want to maintain whatever motion it's in. So if it's at rest, it's going to want to maintain being at rest. If it's moving, it's going to want to maintain moving. And if you leave something alone and you don't have any friction on it, it's going to just keep on doing whatever it's doing. So as long as you don't place any other forces on it, it'll keep on doing whatever it's doing. And I don't know if you've ever seen, that picture refers to a Bugs Bunny cartoon, which I don't know if you've ever seen with a bullfighter. I love the Bugs Bunny cartoons. But anyway, so that the bull is flying through the air and he's pretty much being left alone. Eventually he hits something, at which point he's not being left alone anymore. But as he's being left alone, he's flying through the air, he's continuing his motion. So his first law of motion, which is going to lead into the second law, which will lead into the third, so they all kind of lead into each other. The first law says objects that are at rest will tend to want to stay in rest, and objects that are in motion will tend to want to stay in motion. So that's going to bring us to basically two different categories. Objects that are at rest will stay there, and objects that are in motion are going to stay in motion. And that's as long as you don't have any external forces acting on, unbalanced forces. So these are for objects that are in equilibrium. If they're at rest and they're in equilibrium, they're going to stay at rest. If they're in motion and they're in equilibrium, they're going to stay in motion. And as long as the acceleration is zero. It's not until we start talking about, you know, how do we make an acceleration that's not zero? Well, that gets to the second law. But for right now, the first law talks about what happens if there isn't a net force. And whenever there is not a net force on an object, it's going to maintain whatever motion that it's in. It won't accelerate, it won't maintain it will maintain its state of motion. So that brings me very quickly to the idea of inertia, and inertia is a term that Newton coined, and it basically is related to the mass of an object, but it's the property that makes an object want to resist accelerating, or makes it want to maintain. Another way to say is it's a property that makes it want to maintain its whatever state of motion it's in. It doesn't want to change its motion. So things that are more massive have more inertia, and therefore they have more resistance to acceleration. So to get them to accelerate, you'll have to push on them more. You'll have to put more force on them. So if you think of something very large, like a big truck or something, you're going to have to put a lot more force on it than something small, like a little toy car. A little toy car doesn't have much inertia, so it doesn't resist a change in motion as much. The more inertia an object has, the more it's going to resist its change in motion. Okay, so that's the end of the first law. There's another video on the second law. We're going to do some demos in class tomorrow with the first law. and some practice with the second law.